Okay guys, in my last video we left it where the owner of the tractor was taking this pump back to the guy that rebuilt it, and he explained to him what we found in here, that he had put the thrust bearing in on the wrong side, and it pretty much just totaled out the pump. And the guy was very apologetic, and he said he's going to make it right. He said he's going to, rebuild the pump back and not charge him anything. And so I figured that was as good as we could get. And it's, we all make mistakes, and it's how we take care of the mistakes that really show what we're made of. And so this guy stepped up to the plate, rebuilt the pump. Now I'm back going to put the pump in, and I thought I better, since there's an O-ring up here, I was going to take the nose off just to make sure that he had installed or put the pump together correctly, at least this end. And before I took it apart, I noticed this gear here. It can rub against the housing over here, and so we already have issues before I even take it apart. So I've already took the tack nut off here, the retainer nut for this tachometer cable adapter, and I'm looking in the end here, and it's hard to see, but I don't think he's put a washer underneath that bolt, and there's supposed to be a washer there, and I know that because it shows one right here. So anyway, I'm going to set the camera up, and we're going to take this apart and see what else, what other kind of issues we're going to run into. But I'm not going to install it like that. Okay guys, the bolt, the retainer bolt that holds this gear is also the drive mechanism. It's got a slot in it for this tack adapter to fit into, so this will spin the tack. It's keyed here for the tack cable, and so it's a double duty kind of retainer. And so all we need is a flat blade screwdriver and another flat blade screwdriver to hold the teeth here. I was going to hit on this. This would probably work for a while, but at the bare minimum you're going to get a noise while this pump's running, especially if it's not pulling. And so that's not right at all. So let's get this retainer out, this bolt. And that's all there is to it. I'm going to look in, make sure that, yeah, there's no washer in there. There's supposed to be a washer underneath this head of this bolt, and I can see the bolts still got issues too. This was an issue with the bolt originally, that it was stripped. I showed that on my last video here, and the owner showed the guy that it was stripped. There's hardly any threads left on that. It's pretty smooth. So that there is an issue. Plus there's no washer there, and when I sent the pump back, it did have a washer. So he didn't get the washer back in place, plus he didn't get a new bolt. I figured he'd get a new bolt. So what I'm going to do is I'm going to put it back together, and I'm going to tell the owner of the tractor that it's still not right, and he needs to take care of this issue. So anyway, I'll let you know what transpires. The owner of the tractor has lost confidence in the guy, and so the owner bought another rebuild kit for me to rebuild the pump myself. And here's the separator plate, seal, gaskets, springs, check balls, and this is the issue here. This bolt here, it has a cutout in it for the proof meter cable to fit into. To make a long story short, we're gonna tear it completely down and put another rebuild kit in it, and so we're just starting from scratch. So what I'm going to do, I'm going to mount it in the vise this side down. We're going to take this assembly off here and we'll just get started with it. When I take this end off evenly, you notice I took out these 4 bolts completely, and then I just loosen these up so I can back them out by hand. I don't need anything flying all over the shop floor. So it does look like initially he did install a new plate here. Now this, you can see here, this is supposed to be a bolt right here, and he's got just a Phillips screw in there, just hand tight. I mean, I'm pretty sure whatever's supposed to be in here is supposed to be tight. It's been about, I'm going to say it's been 35 years since I rebuilt one of these pumps, but I'm pretty sure that's supposed to be a bolt. But we'll find out in a minute. I'll check the manual out. So I don't know why this one, can you see why this one is real shiny, like something's been hitting against it, and then the rest of these ports don't have that? Maybe there's another issue we're not seeing. So we'll check it out. Got new springs in the kit, but I was just making sure none of them were broke. Then we got some check balls down in here we'll get with a magnet. It's a good idea to have an area on your bench where you put all your used parts so we can reference those in case there's any differences on the new parts going in. So just don't take all this stuff and toss it in the trash right away. Okay, down in here there's check valve seats, and in the manual it says we need a special tool to pull those out, so we may have to make something or improvise or buy that tool. I don't know. I can't remember. My memory's going after 35 years. So anyway, I'm going to flip it over and we're going to pull the nose off and pull these pistons out from the other side. I'm going to go ahead and take this adapter off, this retainer off right now. I'm going to cheat and use an adjustable wrench. And also when I inspected it the first time, I noticed that there's no gasket right here. There's supposed to be a gasket, and I see the owner of the tractor here got me a gasket. So just another reason why that guy screwed up on the rebuild. So here's the proof cable drive. This would be the driven part of it. The drive would be the actual bolt. We can go ahead and take this out. This bolt here is what's stripped that's holding that gear on, which in turn lines up with that groove. And then this turns with the rotation of the hydraulic pump, and then the tachometer or proof meter cable, whichever one you want to call it, goes into here. There you go. This will come right off without any issues. So we've got no issues here. This is the wobble shaft here. We'll check that out in a minute. You've got a, now the gear can come out, and the gear was put in correctly. It goes in this way. There's a divot on this side of the gear which goes outward. So we have a seal and a needle bearing inside there, and we have the tapered bearing that rides on this outer race right here. So we're going to make sure that bearing is in good shape before we put it back together, because since it basically just kind of blew apart previously, there's, you know, could have got a lot of metal parts in it. So we'll check it out. If you remember on the last video, or the video before that, when I took it apart, I could tell that it was put together wrong. This is the correct way it's supposed to be. Wobble shaft, thrust bearing, and a thrust washer. So, and what had happened was he'd put it together like this, and so all these little roller bearings was rolling on all these little pistons. So, and it just disintegrated. So, this is the way it goes. We'll check out all the components in a minute. These are the pistons that compress the hydraulic fluid. Just want to make sure they come out nice and smooth from their bores, and they do. I mean, they fit really nice and snug too. So I believe we're going to have an empty case here. And so what I'm going to do is I'm going to take that over to the, well, first it looks like I'm going to scrape this gasket off. And then I'll take it over the parts washer and get it nice and clean. Alright, we're going to scrape this gasket off. Should come off relatively easy. They should have been changed out on the last rebuild. Okay, I got most of the gasket scraped off, so what I want to do is I'm going to take just a bastard file and finish removing the gasket, and plus making sure the housing's flat and deburring all at the same time. I'm just going to do this until everything's nice and flat. Just go in different directions Don't sit here and keep your file up here. Just keep your fingers on it nice and flat. Push your file this way. Every file has one direction it cuts and one direction it won't cut. So if you take a file, they're all made to go like this, away from you at that angle to do the best cutting. I can see we've got a lot of low spots and a lot of high spots. So I'm going to work around here, try to get this flat. The gasket will take up a lot of, imperfections. It's not like this isn't like a precision instrument here. Okay guys, I've been messing around this thing trying to get these seats out, and I would have to tell people working on these pumps to get the seat removal tool at the very least. But I got one of them out, and I'll show you how I did it. If you had the proper tool, you would insert the tool into the seat, which is driven down in these bores, and the tool goes past the seat and expands, and then it pulls the seat straight out. That'd be perfect, but I don't have that. So what we have is inside this housing, you can see you can see light through those holes there. That's where those seats are, and it's not a straight shot. It looks like it's a straight shot, but this actual lip of the housing kind of gets in the way to get a drift punch down in there to drive it out. So what I did was I took a screw and I ground the head where it would just drop in to that housing bore and catch the lip of the seat, and then I can get a drift punch, a skinny drift punch or a screwdriver, and tap the seats out. So that's what I've been doing. Well, actually I did one. I see I was successful, so I'm going to continue on. So I take this screw that I altered, and I'm going to drop it down in to the bore. And the first little bit, I'm going to tap it with a drift punch. And I can feel it starting to move now. And now I'll take a skinny screwdriver here. And there you have it. So just be careful on the other side. right before the seat wants to come out. The seat actually fits down in there, and then there's like a this cutout here for oil passageway. The seat wants to rock right there and can get hung up. So just be careful. Don't just keep driving it really hard, because you might be able to break the housing here or screw up the bore where this drives in. So just be careful of that. So I'll continue around. When I get them all out, I'll get back with you. Okay guys, I got all the seats out. Here's an old seat, and of course they press right into here. And I don't have the proper driving tool for it, but I went over to the bench drawer there, and I found a comes off a air chisel, and this is the part that goes into the tool. And that diameter, this diameter to this seat diameter, there's only 0.005 of a difference, this being smaller, so that's going to be a perfect driver. So what I want to do is make sure this is nice and flat, and I want to hollow out the center part just a little bit make it kind of concave, so when I drive the new seat in, I've got no interference of where the ball's going to seat on the center part of that. So I just want the makeshift punch to drive in on the outside perimeter of the seat. And so I'll show you how you put a slight concave on a driving tool with a bench grinder. Basically what you're going to do is hold it perpendicular to the grinder, and you're going to spin it, and that will put just a slight concave face on here and leave the outside just a little longer, a little proud. Also puts a some pretty nice cool marks on it too. But and then once I flattened it off, then I knocked that little burr off there real quick, and now it'll fit right on that seat just like we need it to drive it in, and that way it'll stay away from the inner part where the ball seats. So hey, I'm improvising here. If I worked on these every day, I'd have the proper tools, but sometimes we just got to do what we got to do. All right, back to the bench. Okay guys, what I've done is I re-washed this in the solvent, and then I sprayed it down with brake cleaner, and I blew it all out and off. And then I took my my old man flashlight. When you get probably in your mid 40s, especially in your 50s, you'll know what I'm talking about. And I looked down in here and made sure the bores were nice and clean, no burrs, no debris, and so we're good to go. I noticed that the new seats, they have a chamfer on one end and a chamfer on the inside also, and when I took the old seats out, I noticed that that was in the down position, and I was looking in the manual, and the manual doesn't tell me which way this seat goes. So but when I set the ball on top of this chamfer right here like this, the inner edge has got a chamfer. It doesn't appear to fit the ball. Yeah, there's a gap between the chamfer and the ball, so it can't be that way. So it would go this way. This is more of a square cut edge on this side, and of course the ball would definitely seat on there and then kind of wear itself in. It would take no time to break that ball into that seat. So I'm confident that that seat was put in, the old seats were put in correctly, so I'm going to put them in that way when I go back together. So we'll just hand start this. Well, that dropped all the way down, almost. Not all the way down, but I might as well get them all going there. And so I've got them all started now, but I'm going to check again. I need to pull my glasses down and check real close and make sure they're all the same, and they are. And I'm working right on the top of this metal bench, and my buddy built this bench. It's custom made. It's a 3/4 inch piece of plate steel, machine flat, and so this is a perfect place to you know, do some hammering on. So now we're gonna hold this driver up nice and flat and start them in. Okay guys, I got all the seats in, and I'm going to make mention that those drive in extremely hard. I had to dress my driving tool 2 times, so the original time and then 2 more times, because they were so hard to drive in. And they're all the same height, and I made sure they were seated from these holes back here, those little holes. You can look down in there with a flashlight and see if it's seated. But man, those things those seats were tighter than they needed to be. Almost to the point where I thought I was going to crack the housing or something. I was having to drive them so hard. But once they seated down, of course, then they rang out on the hammer, so I knew I was okay. All right, we're going to start taking these springs off the valve plate here. We'll be replacing those later. And then, if you remember, when I first took it apart, there was just a screw put in here. And the manual shows, the repair manual shows an actual bolt actually holding down the center here. And it makes sense because you have perimeter bolts here squeezing all this sandwich together, but you don't have anything in the center to keep it from puckering out or pulling that down and sealing off. And so that's why they put a bolt in the middle, which this wasn't doing anything. It was loose. So again, probably a good thing we are rebuilding it again. So I got to be careful knocking this plate out, because there's balls and springs behind here. What I'm doing is I'm just coming from the back and catching the lip of that plate. And this hole I was able to catch a part of the lip, but the rest of them, it was pretty flush. But this one, I can get a little bite on it, so I'm going to hold this plate and my drift punch and then tap on it. Okay, the plate came loose, so we'll flip it up here. You can see it. And then, there we go. It looks like to me that this plate's used, that the guy that rebuilt it not too long ago put a used plate in it, because we've got a big wear pattern here where the balls were hitting. And I know that after the guy rebuilt it, it didn't even run for an hour before it blew up, so that couldn't have happened in that time. Then we've got another set of springs. And then now we've got a gasket to contend with, so I'm going to start trying to scrape it out of there. Anyway, I'll get back to you when I get a little farther along. Okay, the gasket was really stuck and really hard to get under, and once under it I couldn't push it by hand, so I'm using this as a chisel, this putty knife. I sharpen it up and I'm tapping it with a hammer. And you just got to go by feel. You don't want to do any gouging, just nice little light taps. So now I've got all this to clean up, and that I will do by hand. Okay, I got most of the gaskets scraped off of there, and so I'm coming in here with some emery cloth and getting the remaining gasket out and shining up the housing, ready for a new gasket. Okay, I'm just taking inventory of the parts I'm going to need to let you know, fill you in what I did. I went ahead and sanded that out some more. Got it nice and shiny. I dipped and brushed this out with solvent, and then I sprayed it down with brake cleaner and blew it out. I did that twice. Make sure there's no emery cloth grit in there or any debris. So now I'm just taking inventory of the parts I'm going to need. Now, this is the new plate, and as you can see where the balls seat, they're nice and square. And here's the old plate, and they've had a lot of wear on them. And this pump was supposed to have been rebuilt. Like this pump's got less than an hour on it, supposedly after a rebuild. And obviously they didn't do a complete rebuild, if they did one at all. So anyway, this is the new plate. We've got to, I want to go ahead and find a gasket that fits that. This gasket here was this type of gasket. I'm pretty sure. I'm gonna verify by pulling the old one out of the trash. Yeah, that's the gasket I pulled out, so that's the one that goes in. Also, there's a notch here, and those go toward the manifold here. So I'm just gonna eye that in there. Make sure everything lines up. Everything's perfect, so I wonder if it'll line up any other way. Let's see. No, you got a hole off that way. Hole off that way. Holes off that way. That way's off. That way's off. So there's really only one way that this gasket will go on there with everything lined up. So you can't screw that up. Alright, the next thing is we're going to drop in new check ball springs into here. So I'll get those ready. Okay, I just matched these up with the old ones. These are the new springs. There's alignment pins in here which are made out of roll pins, and so you just put the springs over the top of those. There's no orientation on these springs. They're what would be called a square spring. It's the same on each end, so either way will work. And then next we're going to drop the new check balls in. And then we're going to put the plate on. And this has got some anti-rust coating on here, so I'm going to clean all that off. And then also I need to find a bolt to go back in here because we're not putting this screw back in. So I'll get back with you when I get ready. Okay guys, I found a 1/4 by 20 bolt. It's going to work just fine. And the gasket has a alignment notch over here, and so does the plate, and so it makes it easy to line up. Kind of just drops into place there. Push down, align your holes, real accurate. And I don't see a torque rating for this, so I'll just, I mean, the old screw wasn't even holding it all, so I'll just do this by feel. So you can see where that bolt's important to seal off this side of the check balls right here, and then the perimeter bolts seal off out here. So without that being tight, you could have some leakage from one port to the other. So anyway, now we've got to put some springs here on these pins, which again are just roll pins drove into that plate. Now these springs have a small end and a large end. So the small end goes over the pins, and you need to turn them clockwise to get them started. And once you get them started, you can bring it on down and seat it like so. Don't just start them and leave them like that. That's not the way to do it. You get them started, use your fingernails or screwdriver, whatever, and go ahead and seat that all the way down. You got to forgive me, I've been clearing my throat a lot. I got a sore throat. Okay, we've got all the springs on there. Just make sure that they're not binding and that they haven't crossed over each other on the springs. So make sure you check all that. And then the gasket that goes on here has a notch. You line it with a notch, and everything lines up perfect here. So I'm going to set this assembly to the side and start working on the nose of the pump. Okay, I'm going to show you what I'm trying to do. I was going to replace this seal, and that seal, the outside diameter of that seal is larger than the inside diameter of the race. So you go, well, I'll just drive it out from the other side, and the other side you have a slight angle. You can get down in here, barely touch the seal, and from here you can see that you know, you can't really do anything. So I've been trying to figure this out, why those genius Ford designers did something like that. So I don't have an inner race puller, so I'm going to mess around with some pry bars and get under here. And also, to let you guys know, this race never was seated down into its bore. It's up, probably 3/16 of an inch from where it should be seated down in there. So that's just another issue. So I need to get that seat out so I can get the seal replaced, and then put the seat back in all the way down. So once I figure out a way of getting that out, I'll get back with you. Alright guys, we left it where I was trying to get this bearing race out, and there was just no way of driving it out from the opposite side like you normally would a bearing race. And I didn't have a small enough puller to get in there, so what I did was, okay, I bought this 3-jaw pilot bearing puller, and I had a 20% off coupon, or 30, I don't remember, but anyway, it was like $17.50, and I thought it might work for our application, so I picked that up. The only problem is right down here where the hooks are to grab the bearing race or whatever you're grabbing, they were not shaped correctly for our application. So I took and ground them. I ground the length off, and then I sharpened them up a little bit, and then I took a triangular file to them and shaped them just the shape we need to get into our bearing race. And so I'll set the camera up and hopefully we can pull it out. I've got to reposition everything. Then you can see I can put a wrench on here and now pull this assembly up through the brace. And so let's see if the race comes out. I hope it does. I want to reposition my tool. Get my fingers here underneath the bearing race again. Now that I've got the bearing race up a little bit, I can get the fingers under a little deeper. There, that looks really good now. Lost my Allen wrench. Yeah, if it just works one time, I'll be happy. I know there's different ways of taking that bearing race out. I could have ground some of it maybe and split it, or I could have welded on it and shrunk it. But to be honest with you, the bearing felt real good and I was wanting to use it over again. So yeah, that worked out really well. And I didn't alter the puller enough where it wouldn't work on anything else. So pretty unique puller here. You can see how the one handle spreads the jaws, and then this nut pulls it, and then this whole bridge assembly is adjustable. So all for about $17.50 at Harbor Freight. If I was doing this every single day, I maybe might buy a better one, but shoot, I mean, this is working. You could buy, I saw some of the ones online like Snap-on and OTC for like $100, and they were similar to this. So hey, good enough for me. I just think it's silly that the Ford engineers designed this bearing race smaller than the actual seal, because I mean, you probably change this seal out 2 or 3 times, maybe more than that, and change this bearing out, you know, a lot less than the seal. And so it would have made more sense if they would have made this bearing just like an 1/8 inch larger in diameter, or the seal an 1/8 inch smaller in the outside diameter. But anyway, now we can get to the seal, and it was a good thing we pulled this out anyway, because remember I told you this race was not down on this shoulder. When I looked at it, it was up about 3/16 of an inch. So we can clean up any burrs, and then when we put this back in, we can make sure it's seated all the way. So I just putting a big pry bar in there. Bring it on out. It's a big pry bar, but you can use a smaller one. Anyway, so we have a needle bearing in there that the shaft is supported on that end, or also called a Torrington bearing. And so I'm going to go over the solvent tank and clean everything up real good, and then we'll check that bearing to see if it's bad, and then I'll show you how to check the tapered roller bearing properly to make sure it's, you know, still good. So I'll get back with you. Okay guys, here's the proper way of checking a roller bearing. So what you do is you clean it all the way up. I'm not taking it off the shaft because I'm checking it. If it's bad, I'll take it off. But anyway, you clean it all up and you blow it dry. Spray some brake clean in there, whatever you want, blow it dry. Don't spin these bearings up being dry, that can hurt them, but you can spin them a little bit when you dry them if you want. But anyway, so what I'm saying is get it nice, clean, and dry. Then what you want to do is you want to go ahead and put just a little bit of oil on it, and you want to work it around like so. Now I'm going to show you how not to check a bearing. You can't spin it like that and go, oh, it feels good, so it must be good. That doesn't tell you anything. What you want to do is check each roller for any erosion or pits. Each one of these, spin them. And you could do this without putting the oil on. I'd already done it and I forgot to tell you. But you check each roller, spinning them. So this rides on an inner race, these rollers do, and you can't see that. And that inner race can be bad. And the best way of checking that is you squeeze your bearing and you lock a couple of rollers, 2 or 3 with your fingers, and then you skid those across the inner race, and you try to feel for any rough spots. And so you want to make sure your bearing's got some lube on it, or it'll feel bad. It'll kind of, I don't know, it's got a weird feeling to it. But if you put a little bit of oil on it and you squeeze a couple of these rollers and you turn, it should just feel like real nice and smooth, no bumps, kind of like almost like glass. And so that's how you check that. So this is a good bearing here. The same thing on this Torrington bearing, this needle bearing. So I've already cleaned this and blown that dry with some brake clean, and so we'll put a little oil on there and we'll roll it around, and then we'll push with our finger on it and lock some rollers and spin it. It's a little harder to do. You may have to get a thumbnail on 1 or 2, but you want to skid that around and see if you feel anything rough. And this one feels smooth too. I also want to make note, there's some burrs right here where the seal goes, and I may have created some of those, and then probably for the past 50 years of it being worked on, it's someone's, you know, got some burrs there. And also here where the bearing race is, there's some burrs. And I believe that's what held that race from going down and seating on this lip here, on this seat. So I'm going to come in here with a file and clean up some of these bigger burrs and some raised metal, and then take some emery around there. And then since there's a bearing down here, I'm going to go ahead and clean it again and blow it dry and feel it just to make sure there's no grit in it. And once I feel satisfied with everything to go back together, then I'll get back with you. But it's basically taking a file, and you can take a file, this is just a 3-corner triangular file, and take it and knock burrs off this way with a file. And then once you knock the burrs off and raised areas, then we want to hit this with some emery cloth. And then also up here where the race goes. And you can also take and grind this sharp and come in here, right here on the seat, and you can do a cutting, scraping motion and actually take burrs off down here. So this one's not ready to cut, but I'll go to the grinder and I'll cut that, and then I'll come back. Okay, basically by flattening off the end, you've made 3 nice cutting surfaces. So I can go around here and basically cut and scrape this bottom seat here and make sure there's no burrs standing up. And that's cutting really good. I mean, you can hear it and I can feel it cutting that metal. I'll take any burrs or raised metal off this flange. Now I'll take a little emery to it. Okay, I think I got it. Now I'm going to go rinse it, clean it really well, since now I have abrasive in here and could have got in the bearing, which I'm sure it did. So we'll get her cleaned up and I'll get back with you. Okay guys, I got it all, everything all cleaned up, burr free, nice and smooth, blowed dry. I checked the bearing again, it's nice and glassy. And so we're ready to put the new seal in. And I noticed the new seal, it looks like the seal that I took out, but neither one of these two seals, the old one I just took out and the new one that came in the rebuild kit, are identical. They're aftermarket, they're both made in Taiwan or China, and they're both different configuration than what the manual shows the OEM Ford seal was. The OEM Ford seal, you can definitely tell which end goes in first, but this one here, it's really hard to tell. So I'm going to put it in the way that the old one came out. Plus, in addition to that, by doing that, there's a double lip seal, and this lip, this diameter is slightly smaller than this one, and I don't know why, because it's fitting on the same shaft. But anyway, I'm going to put the smaller one toward the pump, and then the little larger diameter toward the gear. And again, that's the same way the old one came out. Now, one thing when you're working around hydraulics is this stuff here is a no-no. You use this stuff sparingly anyway around engines, but especially on hydraulics, only use what's specified. A lot of times what they'll show on especially old tractor books, they'll say you know, you might put some grease on a gasket or something like that. But what I'm going to do is I'm going to put a very microfilm layer of copper coat right here. I'm not going to get carried away with it, and it'll kind of help lube it going in and give a little extra seal. But you don't want to get carried away with any type of sealants around hydraulics. You pretty much use the O-rings or the gaskets that's sent with it, and if your book says to put something on it, then go ahead and follow that. But most generally you just put the gaskets and seals on and you run with it. But anyway, that's what I'm going to do, is put a microfilm coating on there. I'm going to just about dry this dauber up, and really you don't need any more than that anyway on something so tight fitting. So you can see it's just a microfilm here. So nothing all running out or anything. And I couldn't find a seal driver, so of course we got to use old trusty sockets. Make sure your sockets are nice and clean. I sprayed brake clean on this one and blew it out, and then I also flattened the face of it, and it fits this seal perfectly. But it did have a ridge toward the center of the inner part of this socket, which actually would have hit right in there. So by grinding that flat, now it hits this whole flat area. So you just want to make sure you have proper drivers. Make sure you start square. You kind of do it just by feel. If you driving a seal in, you can tell your driver's getting cocked, then you need to come over and tap on the high side before it gets out of hand. And there's nothing saying that this is a race, so just make sure that you, once you get it going, it's a little easier. So we're seated out good. Blow any loose, anything that might have gotten in there. And so now we're ready to put the old race back, and you just do a visual check on that. And I've already done that. This is in good shape. So you can start the race dry. Sometimes, since the race is proud like this, I'm going to get it started like so. Now you don't want to get carried away with the hammer, because your hammer is hardened and also your race is hardened. So if you feel any resistance at all where you're going to have to really hit with a hammer, you want to change over to a drift punch or something softer. So if there's any damage to be done, it's done on the driver, on the punch. And so I'm just doing it this way because I'm kind of lazy and I got a feel for it. A punch here that I've already squared off, and I chamfered slightly there, and so we're going to work that around on that edge and drive it down. And this just takes a little finesse. No need to rush on that either. Once you get that bearing down a ways, you can just tap it around in a circle and take it on down. Oh, no, we're seated. Yep. Okay, we're seated down good. I thought we were, but it looked, there's just a little step on the bottom of the race, and it looked like there was a gap there, but no, we're good. All right, so I'll see what my next move is, and then I'll get back with you. Okay, before we do any assembly, I blew all this out again, checked the bearing one more time, and also it's good to make sure that your springs are still on your seals. So sometimes, and it didn't happen here, but sometimes you get a little wild with your seals, or you scrape this with your driver or something, that spring can fly off, and on any seal. So you always want to make sure that they're still on there. And then what I'm going to do is I'm going to swipe some grease in here to pre-lube the bearing and the lips of the seal, and then we'll assemble it. So we'll just take a little grease. So everything from that seal this way toward the pump is lubricated by the hydraulic fluid or oil. Everything on that side, which would be the Torrington bearing, needle bearing, is slung up off the drive gear here. So until that happens, you want to get some lube up, especially on that needle bearing. Before I put this bearing in, even though I've already put some oil on, I'm going to put some more oil right here on it. not extremely necessary, just a little coating. And we want to load this gear in the drive, and you'll see that this gear is machined flat on this side and it's got a divot on this side. The flat side goes toward the inside of the pump. But just don't slam that shaft in there. You want to push and turn. And then now we're going to line up the splines as we push and turn. So you can see the wobble shaft in motion here. I mean, that is simplistic genius right there, using a wobble plate. It's the piston's basically right on here. Of course, there's a thrust bearing in between here, like so. But I just want to show you kind of how this works, because it's so ingenious. Basically, a wobble shaft either transfers or takes lineal motion and turns it into rotational motion. In this case, we're taking rotational motion and changing it into lineal motion. And so you have pistons that ride in here, and the pistons are fixed, so they don't rotate around like this with the wobble shaft. They stay in one place, and as the wobble shaft comes around, they go up and down like this. So as you can see, it's pumping there, and then as it comes down, it's suction. So we got pressure, suction, and you position however many on here, 1, 2, 3, we got 6 pistons here, and you position them around here, so it's almost a continuous motion of pumping action here. And it's just genius. Whoever thought of this is an absolute genius. I don't know why combustion engines there's not more research on combustion engines using this. But anyway, that's how that works. So I haven't even cleaned this yet. I just wanted to show you. I got a little excited. So what I'm going to do now is we're going to put the washers in here and the bolt that holds the gear to the shaft. And just be careful, you don't want to turn this up and let loose. That shaft will fly out. Okay, the owner of the tractor ordered the new bolt, washer, and lock washer. And this was stripped on the old one, remember, and then it didn't even have any washers, so it's going to go on like this and go through this hole here. Okay, the owner of the tractor got a new bolt, lock washer, and flat washer from a supply house, and so we're going to assemble that now. 7/16 socket. Load this up. And we'll snug that up. Now, I don't know if there's a torque specs for that, but I'm going to try to find it. So anyway, let me read the book and get back with you. If not, I'll just have to tighten it up by hand. Okay guys, I could not find a torque spec for that bolt, so I'm going to do it by feel. I'm going to have to lock the gear, and I'm going to turn this bolt by hand and get a feel for it. Okay. I feel good about that. Sometimes when you don't know what a torque spec is and you start tightening it and it feels good and then it starts to get loose again, so you know you're just about ready to pull or break that bolt, and I didn't get to that point, so I know I'm good. I don't know, someone might watching the video might know what that torque spec is, and if they give it to me, then I can simply just pull this adapter here off the tractor and leave the pump in place and get in here and re-torque that bolt. So if any of you professional Ford guys know what that torque is, let me know so I can torque it properly. Alright, now we've got the proof meter cable adapter here, and you can see that we've got some spiral cut into that, and what that does is while this is spinning, it spins where any oil that gets in there is brought back into the engine, so that way any oil that gets on here isn't forced up in here and then up your cable and up into your meter. And there's a lot of shafts in the world that's built like this. It's got these grooves, and that's what they're for. So it's, you know, you get oil in there and it'll just bring it right back out as it spins. So here's the adapter, and I believe this end goes toward the proof meter, yeah. And we've got a new gasket for that. And so we'll put just a little bit of oil on here. And another reason why there's that oil direction groove is there's not a seal right here. So we're gonna put this in, and we're gonna spin the gear and make sure that that adapter and the groove on that nut lines up, and it does. I mean, there's no way you can get that adapter all the way seated without it being engaged, but you can look. Everything feels fine, so I'll tighten that up, and then I see my battery's getting low, so I'll get back with you. Okay, you can see I put the main pump body in the vise, and where I drove those new seats in earlier, I'm going to drop in the new check balls. What we're going to do now is I'd already placed the gasket on this assembly here, but we're going to take it off and put it on here, and line up, make sure the holes line up. Let's see, it's either there or there. There we go. It's got the little notch here, and I know it goes toward the manifold, the tube, and it could have went here or here, but it goes here. And I noticed in the instructions it said put a little grease on it. So this is what a lot of the tractors say to do on a lot of gaskets, is just put grease on them. Okay. Now I'm going to get my retaining bolts that bolt this in onto here cleaned up and ready to go, then I'll get back. Okay, I got my bolts ready, cleaned, and I blew them off, and these actually have a torque spec on them, 40 to 50 foot-pounds, and since they have a torque spec, we want to make sure we lube them. We lube the threads, and just underneath the head of the bolts. And then that'll give us our proper torque spec. Now when we put this assembly over the top, these springs are not going to fall off because we put them over the pins, the alignment pins, and this plate's not going to come off because we now have a proper bolt that holds it on there. And these manifolds line up, so that should be self-explanatory here, just to make sure. Okay, you can see I got all the bolts in, and I'm just going to snug them. Now what I'm going to do is, this is supposed to be torqued between 40 and 50 foot-pounds, so we'll torque it to 45, but we'll do it in 2 increments. So I've got the torque wrench here, and I'm going to set it to 20 foot-pounds right now, and we'll do it in 2 stages, 20 foot and then 45. Okay, that snap action torque wrench was bad, and so I got a beam type torque wrench here, and it's just as good. So we're going to go to 20 foot-pounds first. We'll go to 45. Basically, as you put pressure on here, this head, this bar here bends, and then this pointer shows you how much this bar is flexed, and that'll give you your torque rating here in foot-pounds on this particular model. So we're going to go ahead and do this to 45 and be done. I'll get back with you when I'm done. Okay, I've got it all torqued down. I just want to tell you that since we're compressing 2 gaskets in there, that I went around one time and then I went back and checked and it already compressed again. So I re-torqued 3 different times, and finally all the torque specs are holding. So now we're going to flip it over and insert the piston and springs. What you're going to do is inspect each piston, make sure there's no burrs or scratches or anything, or if there's any weird wear pattern on the end where the wobble shaft rides. Actually, the wobble shaft doesn't ride on it, a thrust bearing does, but you still want to see if all these ends of these pistons look the same. See if there's any scuffing or unusual wear marks. So if you see 1 or 2 that look completely different than the others, then you need to step back and take a look at it again. You probably got a couple of them worn. So these look good. Also, these pump returns or piston return springs, there's 2 different sizes in the kit, so make sure you match yours up. And basically what we're going to do is put the springs on. Well, we can just drop the springs in actually in the holes, so that's what we'll do. Okay, since I've already checked out all my pistons, I'm going to lay them on the bench and just squirt a little oil on them so I don't have to do them individually. We'll just drop those in. As you can see, I've got good clean oil on them. So what we want to do is make sure they're all the same height, and you want to push them down all the way down through the bore and make sure that each one there's no catching or binding and that they return fine. In this case they do, so we'll continue going back together with it. So this kit came with a new O-ring here. You can take grease, run it through your fingers like this, quick way of getting her lubed up. Also, I've already checked this thrust bearing and washers, and they look just fine. So I'm going to put some grease on here and kind of stick these together. Also, I'm going to put some grease here on the wobble shaft. So that's actually a bearing race right there that the thrust bearing rides on, and then it actually has another thrust bearing on this side that rides on the pistons, like so. So we're going to have a thrust bearing sandwich right there. And we're all good to go, good to assemble. So we're going to drop this on nice and slow, make sure that the thrust bearing doesn't fall off. That's one of the reasons you put so much grease on it. O-rings in place. So we'll set her on here. Now, these bolts here have a torque spec also. So I've got them cleaned up, but I don't have them oiled here on the bench, so I'm going to go ahead and oil them up. Now this has a spring tension against it on the wobble shaft, because the wobble shaft is wanting to push down on some of those pistons, and so therefore it's keeping it up. And since the wobble shaft isn't flat, it wants to tilt this housing, so you just want to make sure that you get all your bolts started by hand. And then you want to tighten them round and round or back and forth evenly. You don't want to tighten one all the way down tight and then tighten the other one. So anyway, we'll get that going. Okay, you can't get a straight shot on these bolts here. There's two of them that you can't, there's two that you can. So I'm going to go ahead and torque these two here to about 20 foot-pounds, and then I'll do these two by hand, just by feel. So I'll just feel that bolt, how tight it is, then I'll come over here and tighten that one, and I'll tighten this one. Okay, now I'm going to go ahead and tighten this one to 45 foot-pounds. Okay. All right, now 45 foot-pounds is about all you can do with a wrench like this with one hand. So that's what I'm going to do. Since that's an O-ring there, there's an O-ring right here. Of course, you remember we put that in. It's not as critical. I mean, just as long as you get these bolts tight. So I'm just feeling the pump. Everything feels nice and smooth. If I wanted to, I could put a little oil in there. Now we're getting that familiar sound. You probably can't hear it. I don't have quite as much oil in there as I need to get that pumping sound that you get whenever you spin one of these. But I can tell you this, just by turning this, it's nice and smooth. And I want to show you here though, there's two different seals that go on here. And one is a round O-ring, and it goes here. and one is a square cut seal or O-ring, whatever you want to call it, and it goes here. And if you're ever working on anything, hydraulics or, well, just about anything, and you want to know what side the pressure or suction side is, the pressure side 99 out of 100 times is going to be smaller than the suction, because it's harder to pull fluid than it is to push it. And so that's why you see the differences. That's why intake valves on cars are a lot bigger, because it's harder to pull something than it is to push it. So that'll give you an idea. Or if you have two lines going to a pump or to anything, the small one is the pressure, the large one is the return or suction. Okay guys, I went ahead and cleaned the block here, and I put a little copper coat on there. I put a new gasket on. I put a new, I put a thin layer of copper coat on top of that. The pickup tube or manifold is nice and clean. I see my buddy cleaned all that up. And so we're ready to go back with the pump. Make sure your O-rings and square cut ring is in place. And we are going to drop these, since there's studs here, we're going to drop the studs on here, and then this will just automatically line up. Like so. Now we'll just hand tighten these mounting bolts. Okay, these are started, but we don't want to tighten these up first. What we want to do is tighten the pickup tube to the pump first, because this is its weakest link here. Since this is aluminum, we want to marry these together nice and tight, and then we'll go ahead and tighten the whole pump up. There's big flat washers that go on underneath this to spread out the load on that aluminum flange. Alright, we're going to tighten this up by hand. Okay, now that we have this tight, we can come up here and tighten the mounting bolts. Okay, now we'll put the proof meter cable on, and it has a keyway. You just want to line it up with a keyway in here. So it's just a matter of turning it until it lines up. And so there you go. This only needs to be finger tight. If it has a tendency to come loose, you can put some pliers on there and give it a little bit more, but pretty much hand tight. And so now what we'll do is we've already got this the transmission housing cleaned out, because we weren't sure if any metallic particles from this pump kind of exploding got down in anything. So the owner of the tractor has already flushed the hydraulic reservoir out, drained it, dried it, cleaned the tube, drained it, dried it, and he's now filled the all the reservoirs up to the proper level. And so all we have to do is really just prime the pump and start it up and see if it works. Okay guys, basically as you're sitting on the machine, on the left hand side here below where your leg would be is the dipstick for the hydraulic system. So you take this out. Now what we're going to do is we're going to pressurize this port here with some compressed air, and I've turned the compressor down to 40 pounds. There's no need to blow a ton of pressure in here. There's a slight possibility you might, if you have a weak gasket, you might blow that out, or a seal. So all we're wanting to do is just some steady pressure in here, and that'll pressurize this compartment, which in turn pressurizes and pushes the hydraulic fluid up. And see, it's the level is probably already here, because liquid finds its own level, and so since that compartment's at the right level, so we don't have to really push a lot of oil up. But what we want to do is push the oil up into the pump, and right here is the bleeder plug, and so we'll take this out. We will go over there and blow some compressed air in there. It'll bring this oil up, and then what we'll do is we'll quickly come over here and put the cap on before the oil has a chance to run down. And that's just as simple as it is. Now if you got a friend over here, that makes it a little easier. So, but anyway, that's how I'm going to do it. Basically what I'm going to do is I'm going to take my air nozzle, and I'm going to wrap a rag around it here, and I'm going to seal it off, and I'm going to pulsate just like this. Pulsate pressure inside here, and then I'm going to be watching over on the other side for the oil to come out. Okay, I'm going to run over here, put that plug on real quick. Then I'll tighten it up and I'll get back with you. I know you're not supposed to start a tractor standing right here where I'm starting it, but I'm making sure I'm in neutral. So if I run over myself, it's all my fault. Don't ever assume that you've left it in neutral. Always check beforehand. So let's crank it up. I'm in the down position. I'll raise the handle up. Got some air in it. Everything looks good. I'll work it up and down to get the air out of it, and then check for any leaks. Hey guys, I hope you appreciate the how-to videos that I put online, and if you have any questions or suggestions on how I can make my videos better, please leave a comment down below and support me and subscribe. Thanks. Bye.